Hello everyone, welcome to the Calculus 1 final exam review. Today we're going to be looking at a problem that involves a particle moving in a straight line with a velocity function given as 2 sine t minus 4 cosine t and an initial displacement at s of 0 equals 4. And the objective here is to find the position function. So what you see here is that if the derivative of the position function is the velocity function, the integral of the velocity function will be the position function. So in order to find the position function, we need to integrate our velocity function v of t. So here we have the integral of 2 sine t minus 4 cosine t dt. And when we integrate that, we're going to integrate it as two separate integrals. So we're going to have the integral of 2 sine t dt minus the 4 integral of cosine t dt. And we're just going to go ahead and integrate these two functions. So the integral of sine is cosine t plus c, and the integral of cosine is sine. So we have negative 2 cosine t plus c minus 4 sine t plus c. We're just going to combine the two c's. So we have minus 2 cosine t minus 4 sine t plus c. And that is going to be equal to our position function, s of t. So now we want to figure out what c is equal to. And in order to do that, we have to use our initial value condition that was given in the problem statement. So s of 0 equals 4. So we're going to replace all of our t's with zeros and set that equation equal to 4. So s of 0 equals 4. And now we're just going to solve for c. So we know that cosine of 0 is 1 and sine of 0 is 0. So we have negative 2 times 1 minus 4 times 0 plus c equals 4. Equal to negative 2 plus c equals 4. We're going to add 2 to both sides. We're going to see that c is equal to 6. The problem is not finished yet, though, because we need to take this number 6 and replace it in our original s of t function that we see up here. So now we need to rewrite s of t equals negative 2 cosine t minus 4 sine t plus 6 instead of c. And there you have it. So the next problem is a little similar to the previous one. In this one, we are given a acceleration function, a of t equals 5t squared plus 7, and we want to find the velocity function. So we know that the derivative of the velocity function is equal to the acceleration function. So we can use that knowledge to determine that the velocity function is equal to the integral of the acceleration function with respect to time. So if we integrate our acceleration function in this case, we will be able to figure out what the velocity function is. And again, our acceleration function is 5t squared plus 7. So we're integrating that with respect to t. And we can solve this as two separate integrals. So we have integral of 5t squared dt plus 7 integral of dt. So we can take the coefficients out of both of these integrals. So we have 5 integral of t squared plus 7 integral dt. And when we integrate these, the integral of t squared is t cubed over 3. We're doing t to the 2 plus 1 over 2 plus 1. And the integral of 7 is 7t. So we're just rewriting the result and combining our c's. So now we have v of t is equal to 5 over 3 t cubed plus 7t plus c. So now we want to find what c is, just like in the previous problem. So v of 0 is equal to 7. So we're replacing all of our t's with zeros. And we're going to set that equal to 7 and solve for our variable c. So of course anything times 0 is 0. So that just leaves our result c equals 7, which we then plug back into the original velocity function that we have. And the result is v of t equals 5 over 3 times t cubed plus 7 times t plus 7. And that is the final answer. So the next one is similar to the previous two, but in this case we have a cost function and a marginal cost function. So the cost function is the integral of the marginal cost function because c prime is the derivative of c. So if we integrate c prime, we will determine what c of x is. So c prime of x is x to the 1/3 plus 9. So we're going to integrate this function. Integral of x to the 1/3 dx plus integral of 9 dx. And we can move that 9 out to the front. So now when we integrate both of these, the integral of 9 is just 9x. And the integral of x to the 1/3 is x to the 1/3 plus 1 over 1/3 plus 1. So 1/3 plus 1 is going to be 4/3, so we can rewrite this as x to the 4/3 over 4/3 plus 9x plus c. And we're going to want to apply the method for reducing fractions, compound fractions, where we do keep, change, flip. So that's what I'm going to do here. We have x to the 4/3 times the reciprocal of the bottom fraction. So we have x to the 4/3 times 3 over 4 plus 9x plus c. Now this step is just rewriting the previous line. And the next thing we're going to want to do is identify what the conditions that were given were. So we see that C of 27 equals $376. So X in this case would be 27. And that will be equal to 376. So it's important that you know how to interpret the conditions that are given in the statement. And we're going to use those numbers to figure out what C is. So we substitute 27 anywhere that we see an X. And we're going to set that equal to 376. And then we're going to solve for C. So here I applied the cube root to 27, and that is 3, and then we still have to apply the 4th power to it. So we have 3 times 3 to the 4th power over 4 plus 243 plus c equals 376. So 3 to the 4th power is 81. And 3 times 81 is 243. So we have 243 over 4 plus 243 plus c. We're going to subtract 243 from both sides. And we're going to subtract 243 over 4 from both sides. 243 over 4 evaluates to 60.75. So we're subtracting 60.75 from both sides. And we get our answer for C. Now we just want to plug that back into the original C of x equation. So C of x is equal to 3 times x to the 4 over 3 over 4 plus 9x plus 72.25. That's our final answer.